Good morning students. Today we are going to discuss IIT-JEE NEET Foundation. The topic work power energy. In that basic some questions which are related to work power energy. See, basically work is nothing but whenever force acts on a body, body displaces in the direction of the force. Power, the rate of work done. Energy, the capacity to do work is called energy. See, the basic questions like what is work in the physics? See, work in the physics is, just now I told you, whenever the force or it's a transfer of energy, so acts on a body, when force is applied, body moves in the direction of the force. Body moves in the direction of the force. What is the SI unit of work? The SI unit of work is joules. Joules are the SI unit. 1 joule is 1 kg meter square per second square. 1 joule is 1 kg meter square per second square. See, joule is the SI unit of the work. How work can be calculated? Work can be calculated by multiplying the force and the displacement and the angle between the cosine of angle between the force and displacement. The cosine of angle between the force and displacement is called work. See, here work is calculated by multiplying the force and the distance or displacement you can take. The cosine of angle between the force and displacement. The cosine of angle between the force and displacement. So next one is, can work be negative? Yes, work can be negative if the angle between the force and displacement is 90 to 180 degrees. The work is negative only. See, that is in the second coordinate it comes, the cosine of second coordinate angle is 90 degrees. That's why, so the cosine of angle between 90 and 180 is negative, hence the work is negative. So that only same thing. Here the negative work done is nothing but, so the force and displacement are opposite in direction. The force and displacement are opposite in direction or motion. It is against the motion. See, what is the work energy theorem? Work energy theorem is nothing but the entire kinetic energy is converted into work done. Work done is equal to energy. The entire kinetic energy, the change of kinetic energy, net kinetic energy. Change of kinetic energy means final kinetic energy minus initial kinetic energy. See, kinetic energy, the change of kinetic energy is equal to, that is nothing but half mv square minus half mu square. Half mu square is equal to force into displacement. Force into displacement. This is known as work energy theorem. See, the same thing, work energy theorem states that work done on the object is equal to change in its kinetic energy. Work done on the object is equal to change in its kinetic energy. So next slide. What is kinetic energy? Kinetic energy is nothing but the energy possessed by a body by virtue of its motion. The energy possessed by a body by virtue of its motion is called kinetic energy. See, the formula for kinetic energy equal to, kinetic energy is equal to half mv square, where m is called mass and v is called velocity. See, this is the formula. Kinetic energy is equal to half mv square. Half mv square you can write. See, next one, there is, what is potential energy? Potential energy is nothing but the energy possessed by a body by virtue of its position or state. The energy possessed by a body by virtue of its position or state or configuration is called potential energy. The potential energy formula, mgh, mass into acceleration due to gravity into height. Next one, what is the formula of gravitational potential energy? Gravitational potential, same thing, mgh, mass into acceleration due to gravity into height. What is law of conservation of energy? Law of conservation of energy is nothing but energy neither created nor destroyed. It transforms one form of energy to another form. Energy remains constant. If energy disappears in one form, then reappears in another form. Energy, total energy will be remains constant. So that is law of conservation of energy. Next question, what is power? Power is the rate of work done. Work done per unit time is called power. The rate of work done. See, power is nothing but work by time. Next slide. What is the SI unit of power? The SI unit of power is watt. 1 watt equal to 1 joule per second. See, power is nothing but work upon time. Work is measured in joules. Time is measured in second. Joules per second is nothing but watt. So, SI unit of power is watts. What is the relation between work, power and time? See, just now I told you power is equal to work by time. Power is equal to work upon time. So, the same thing. See, calculated power can be calculated. See, energy upon time or work upon time. So, here the relation is work power time. Power is equal to work by time. So, what is the difference between work and power? Work is nothing but the force or the energy which is transferred to do some work. So, that is force acts on a body, body displaces in the direction of the force. That is work. Power is some work you are doing in certain time. Power is rate of work done is called power. See, which requires more work, lifting a 10 kg object 1 meter or see, lifting a 5 kg object 2 meters. If you observe carefully, in this case, which requires, see, 10 kg object you are moving for 1 meter. So, 10 kg object if you are moving for 1 meter or lifting a object 5 kg for 2 meters. So, in both the cases you are lifting an object. If you try to calculate the potential energy of the two cases, see, the potential energy of the first case, the potential energy of the first case here, potential energy of the first case is mgh. So, m equal to here it is 10 kg object, gravity is 10, height is 1. 1 meter you are lifting. So, that is nothing but 100 joules. See, potential energy of the second case, same mgh formula, but mass is here 5 kgs. 5 kgs, gravity is 10, height is 2 meters. So, this is also 100 joules. It means in both scenarios, potential energy of the first case is equal to the potential energy of the second case. You can find out in that way. See, coming to the next. See, what is potential energy? Just to come out of the question and answers, just potential energy is nothing but, see, the energy possessed by a body by virtue of its position or state or configuration, where which is okay, certain height if the body is there from the ground, that is there the body gains potential energy. See, potential energy is nothing but the units of potential energy is joules only, Newton meter or joules. There are different types of potential energies are there. One is gravitational potential energy, elastic potential energy, magnetic potential energy, electrical potential energy. All these are the different types of potential energies. See, potential energy is equal to mgh for gravitational potential energy. The formula, the gravitational potential energy, the formula potential energy is equal to mgh, and elastic potential energy is equal to half into kx square, half into kx square, where k is called spring constant, x is the displacement or extension of a spring, So, there in the initial position when unstretched spring is there, the potential energy is 0, but now it is changed. Okay, the stretched, there is a stretched spring is there, you are stretched by x meters, then the potential energy which is gained by it of kx square. This is called state. See, in initial state there is a spring which is not extended, but in the second stage the spring is extended. So, in that way you can calculate the potential energies. See, gravitational potential energy. Gravitational potential energy is nothing but, there is a formula for gravitational. Due to the gravity, the body gains the energy. So that we will call it as a gravitational potential energy. See, usually, see, from the work done against potential energy is potential or something, the work done to move a mass from one place to another place. Here you are moving from infinite to some point. There the gravitational potential energy formula, you can take it as the gravitational potential energy is equal to minus G into capital M small m by R. Minus G into capital M small m by R. So minus is the negative because here gravitational force is the attractive force. So that's why it's a negative. You have to take. So capital G value 6.67 into, it's a gravitational constant. 6.67 into 10 power minus 11. See, that is the gravitational constant, Newton meter square per kg square. This is the gravitational constant. Capital M is the mass of the object. So small m is, see, mass of, capital M mass of the earth and mass of the objects. See, like that, this gravitational potential energy is also balanced by the, see, when you are deriving the escape velocity. So escape velocity, we will use this gravitational potential energy is equal to the, see, kinetic energy. By using that, you will derive the escape velocity. So just idea, you should remember that there is a gravitational potential energy minus G capital M small m by R. See, next one is electric potential energy. See, electric potential energy is nothing but, here you are moving a charge from one place to another place. So the amount of electrical energy which is utilized, the potential energy which is gained, that we will call it as a electric potential energy. The formula for electric potential energy, see, minus K, sorry, it is either attractive or repulsive force, that's why it is given positive. So K capital Q small q divided by R. K capital Q small q divided by R. Here K is called electrical constant. Okay, so that electrical constant, see, 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. The value is 9 into 10 power 9. 9 into 10 power 9. Epsilon naught is permittivity in the free space. So by using this formula, you can calculate electrical potential energy. Electrical potential energy. So this is another potential energy. So next one, magnetic potential energy. So here magnets, there are poles which are going to be there. There is a magnetism. So magnetic potential energy. Magnetic potential energy, the formula is here, magnetic moment into magnetic induction. See, something like it's a work done only. See, it's a work done, magnetic moment mb sin theta. Normally we will use, instead of m, mu is given here. So here mu is nothing but Ia. Mu is, so Ia, I is current, A is area of cross section. There is a formula in the electromagnetism. So torque acts on an object, NBIA. See, something like in electrical motor, we are going to see all this. That also, it is a something like dipole moment here what used. So current into area into magnetic induction, that is nothing but it is a magnetic potential energy. Magnetic potential energy, the formula what we are using here, it's a dot product between magnetic moment and magnetic induction, that is magnetic potential energy. See, coming to the next, elastic potential energy. Elastic potential energy is the, see, in the springs, usually elasticity chapter it will come. So when spring is in the unextended, that is unstretched spring state, the potential energy is 0, but if it is stretched to a displacement or so extension of a spring, it is x. Then the work done is nothing but, if you apply the integral from 0 to x, so f der dx, the same formula you can derive simply by using the integration method. See, the integration method, the integral energy is equal to 0 to x, see, f dx. So f is equal to here what? 0 to x, so kx minus or x to 0, you can kx dx. That is nothing but k is the constant. So integral of x is nothing but x square by 2. So that is the way you are going to get the half kx square. Half kx square is the formula to have the elastic potential energy. Here also amount of work done to stretch the spring. So I understand. We'll continue in the next video. Thank you very much. Thanks for watching.